let's take a look at differentiability and continuity again. We're kind of just going to do a quick summary. So we're going to make an additional tab that we're going to put underneath the one that we already have. So go ahead and cut it across so that it's still under the tab differentiability and continuity. Alright, so differentiability at a point. So we've got two definitions going for us right now. The first one is what we did before, is the limit as h goes to 0 of x h plus h minus f of x over h. And then we've got the new one that we just introduced for differentiability, which is f prime of x is the limit as x goes to c of f of x minus f of c over x minus c. So you need to know both of them, or at least how to get one from the other. Alright, so remember, the derivative is the limit as the slope of a secant line brings the 2 points closer together. The derivative is the limit as the slope of a secant line brings the 2 points closer together. This is a listening check. Put a circle around the word remember. Circle the word remember. In order to get the slope of a tangent line. In order to get the slope of a tangent line. Alright, so it looks like this, so we already know this. So this would be a secant line, goes through 2 points. And then what we're doing is bringing those 2 points closer to one another to make a tangent line. So going from x to c, or as h approaches 0, whichever definition you want to look at it, so you can make this tangent line. Alright, so that's the entire point. That's what derivative is, which is slope. Alright, so as it is a limit, in order for it to exist, the limit as x goes to c from the left of our function has to equal the limit as x goes to c from the right of the derivative. So in order for it to exist, it has to be approaching from the left and right. When does that limit not exist, or when is it undefined? When does the limit not exist or is undefined? This is a listening check. Box the word undefined. So we're going to look at some situations. We already talked about it, but it's just like a summary of what we've already spoken about. When f prime of x is not continuous at the given point, that's when it doesn't exist or is undefined. So let's take a look at some examples. Let's say we had discontinuity like this, a hole basically. Alright, so you see we can draw tangent lines everywhere, but when it comes to this hole, how can I draw a tangent line? It doesn't exist. There's nothing there for me to draw a tangent line on. So I can't have a tangent line to nothing. So that's why the slope doesn't exist at that point, because I can have a tangent line to nothing. Well, what if I went ahead and filled in a hole somewhere else? Well, in that case, remember what slope is, or what derivative is. Derivative slope, which is equal to the change in y over the change in x, which is equal to y2 minus y1 over x2 minus x1. Well, I need 2 points in order to get the slope, or to get the derivative, or to get the tangent line. But if it's just 1 point, I don't have 2 points. So I can't have a tangent line to nothing or a point for those reasons. Alright, let me take a look at another one. Let's say we had a jump in our function. Alright, so again, we can draw tangent lines on all the way at the left to the almost to the end, and all the way from the right we can draw a tangent line. But what do we draw a tangent line at the end points? I don't know which way the graph is going because it's at the end point. So it's really the same reason we just did with the point and hole. I can't draw a tangent line to nothing, and at that 1 point I only have 1 point. Therefore I can't draw it that way. So I don't know which way to draw the tangent line at the end. So the tangent line or the derivative at that point does not exist. Right, so this is just a couple of examples as to why it has to be continuous, because you know these are all discontinuities. So in summary, must be continuous to draw a tangent line. Must be continuous to draw a tangent line. This is a listening check. Circle the word must. Circle the word must. Now let's take a look at another situation. Let's say we had a vertical tangent line. Alright, so I'm just going to go ahead and draw a vertical tangent line. And remember, slope is the change in y over the change in x, which means the change in y is whatever the change is, but the change in x is 0 because x is not changing. Well, what is anything divided by 0? It's undefined. So I have an undefined slope. Alright, number 3, a sharp point or cusp. So again, I can draw tangent lines all the way on the left, but when I approach that point, I don't know which way at that point, which way to draw the tangent line, left or right. So again, slopes don't agree from the left or right, so which one do I choose? So the biggest thing to take is also for derivatives, the limit as it approaches from the left is equal to the limit as it approaches from the right of the derivatives. That's the huge thing, this blue box, that's huge. Alright, and this is just graphically what's going on. So let's take a look at some questions that you might get asked. Let's say you have this example. And the question is, does the derivative exist at the point 1? So the first thing you do is you find the derivative of f of x for values less than 1. The derivative is 2x. And then find f prime of x for x is greater than 1. The derivative of 2x is 2. Alright? Once you've done that, find the limit as x approaches 1 from the left of f prime. Alright, so the f prime from the left is going to be 2x because x is less than 1. Alright, so that's going to be, as x gets to 1, it's going to be 2 times 1, which is going to give me 2. Alright, then find the limit as x approaches 1 from the right of f prime of x. So the limit as x approaches 1 from the right is going to be 2. So that's equal to 2. So final step, find the limit as x approaches 1 of f prime of x. Well, we know that that's equal to the limit coming from the left of f prime of x, and that has to be equal to the limit coming to the right of f prime of x, which means that it's equal to 2. So therefore, f prime of 1 exists and is equal to 2. Let's take a look at another question that's really popular to be asked. Is the following function continuous and or differentiable at x equals 0? Right, and that function is x squared when x is greater or equal to 0, and x when x is less than 0. This is a listening check. Shade in x is less than 0. First, let's take a look at whether it is continuous or not. Is f of a defined? So in this case, is f of 0 defined? Well, f of 0 is x squared. And plug in 0 in, we're going to get 0. So yes, it is defined. Number 2, does the limit as x goes to a of f of x exist? Which we all know means the limit going from the left of 0 of f of x, which means we're using x as a limit as x goes to the right of 0 is x squared. Does that exist? So put in 0 in, we're going to get 0. There's a limit as it goes from the right, and that's going to be 0 squared, which is also 0, which is equal to 0. Therefore, the limit as x goes to 0 is 0. And then finally, does f of a equal the limit as x goes to 0? Yes, it does, because 0 is equal to 0. So f is continuous at x equals 0 as it satisfies all 3 conditions for the definition of continuity. F is continuous at x equals 0 as it satisfies all 3 conditions for the definition of continuity. So it's proven that the function is continuous. Now we're going to check if it's differentiable. In order for it to be differentiable, the limit as it comes from the left of f prime of x has to equal the limit as it comes from the right of f prime of x. Alright, so what does f prime of x mean? It's the limit as x goes to c of f of x minus f of c all over x minus c. Alright, so let's look at from the left. F of x from the left is equal to x. The listening check, put a circle around from the left, from the right. Because that's less than 0, so it's equal to x. And from the right, it's equal to x squared, because that's greater than 0. F of c, so f of 0 is just plugging in 0, that's 0, and 0 squared is also 0. Alright, so then looking at the limit from the left, making it equal to the limit from the right, plugging it into the definition, we're going to get f of x, which is just x, minus f of c, which is 0, all over x minus 0, equals the limit as it comes from the right. F of x in this case is x squared, minus f of c, which is 0, all over x minus 0. Alright, let's simplify that a bit. It's a limit as it comes from the left of x over x, which is equal as it comes from the right of x squared over x. Simplify that a little bit. x over x is 1, and then x squared over x is x. Then plugging in 1, we're going to get 1 is not equal to 0. Therefore, f prime of 0 doesn't exist and is not differentiable at x equals 0. Therefore, f prime of 0 doesn't exist and is not differentiable at x equals 0. Remember, just because it's continuous doesn't necessarily mean that it's differentiable. However, in order for it to be differentiable, it has to be continuous. Make sure you remember that. Alright, so you can use the long way, which is what I just did by using the definition like that, or you could use the short way, which is what we did here with the power rules. It just depends what the question asks. That's why I did one of each. That way you know both. Alright, so let's practice.